Hey guys, this is help on your worksheet from yesterday. I'll try to make sure I do the two she's going to correct, and we'll finish. Usually we struggle on the back page, so we'll do a few of those as well. My page is all tilted. Sorry, I'm wondering if I can straighten it out here. No, that made it worse. Well, you're going to have to deal with it being crooked. So we are solving equations by factoring. So I think what I'll do is I'll dig right in here with number 4. Remember when you're factoring that your first question you ask yourself is, can I take anything out of every term first? The answer to this on number 4 is a no, but we'll do one where there's a yes for that. Then you look at it and you decide if it's an easy kind or a hard kind. I'm going to tell you this one's the hard kind because you have to worry about how you mix and match the 2D and the 1D that you have to use for your first terms, and the 3 and the 1 that you have to use for your last terms. Something that's always helpful is to look at this sign. Because it's negative, it tells you you'll have one positive and one negative. So what I'm trying to do is mix and match these so that I can come up with this middle term of a negative 1. So I'll try to grab a highlighter so you can see me try to figure out which is my winner. If I match the 2 with the 3, I have a 6. And my other pair will give me a 1. There's no way that I can get a negative 1 out of 6 and 1. So then what I do is I try swapping that. Maybe, sorry, I'm going to erase. So that wasn't my winning pair. It's hard when you can't see me pointing at these. So my winning pair was not the 6 and the 1. What that means is instead of doing both of the firsts and both of the lasts, what I'm going to do is try pairing the 2 with the 1 and the 1 with the 3. Notice the yellows make a 2 and the greens make a 3. I'm going to link those because that's my winning pair. Now I need to add the 2 and the 3 so that I get a negative 1. What that means is my 3 has to be negative. So I'm going to put a little negative right there. Look at my arcs. 2 times 1 is a 2. 1 times negative 3 is a negative 3. And they add up to negative 1. So now I'm ready to sort my problem here. I have the 2D and the 1D, or just D if you want. And look at who I linked the 2 with. I linked the 2 with the positive 1. So since my 2's on the outside, I have to put my positive 1 on the outside. That leaves me with a minus 3 on the inside. Now last week you were done, but your goal today is to figure out what makes it 0. Two things can't multiply to equal 0 unless one or the other is 0. So you're going to say either 2D minus 3 equals 0, which would mean 2D equals 3, adding 3 to both sides. And then dividing by 2, I'll say 3 over 2, or you could say 1.5. But 3 over 2 is one of the solutions to that quadratic equation. On this side, I have D plus 1 that would have to equal 0. That's just a quick subtract 1, and I get D is equal to negative 1. So basically, this is the same thing you were doing last week, except that you now need to find the solution. So you need to set each piece equal to 0. Let's go down and take a look at number 7. Number 7, can I pull anything out of each of these first? Well, there's a 4 and 4 and a 2. 28 has a 4 and a 2 in it, but 49 doesn't, so I'm stuck. So this is not the easy kind, but I'll tell you, usually, if you pick the ones that pop into your head first, normally you'll find your winner. And I can tell that this is going to be my winning pair. I like it when they give me all positives. That's nice. But you'll notice I have a 14 and a 14. So what that tells me is, and again, 14 plus 14 gives me the 28 that I need. So I'll lead in a 2y and a 2y. I'll end in a plus 7 and a plus 7. These are always checkable. I can just grab these and say, is 14y plus 14y equal to 28y? And the answer is yes. But now today we're having this set equals to 0. Since both of these factors are the same, I really don't need to set them both equal to 0. I'll just say 2y plus 7 would have to equal 0. So I solve it. Subtract 7 from both sides. I'm going to go move over here. That'll give me 2y equals negative 7. Divide both sides by 2. And you can just leave negative 7/2, or if you want to go to your calculator and get negative 3.5, that's fine too. But just fine to leave it when it doesn't reduce like that. This had one solution, and again, it's because both of these factors are the same. So I could have set both of them equal to 0, but I would have had that same answer pop up 2 times. My favorite kind is number 10. The reason I like number 10 is because it's a difference of 2 squares, and those are the easiest to factor if I recognize them. Remember, they lead in what I call Samers. T times t is t squared. They end in Samers. 11 times 11 is 121. And we have one of each sign to cause a wipeout on the middle terms. So watch. If I do outside, negative 11t, plus inside, positive 11t, that gives me a 0, which is why you don't see a third term in the middle there. So what does that mean? It means either t plus 11 has to equal 0. Nice, easy, subtract 11. A lot of you would just do that in your head, which means t equals negative 11, or t minus 11 has to equal 0. And obviously, that would give you a positive 11. So these are the 2 solutions to that quadratic equation. Let's go do a couple on the next page. On these, you have to get them equal to 0 first. So let's just right away go up on the top there and take, sorry, and take a look at number 12. So my problem on this one is it's not equal to 0. So the first thing I'll do is move these over. 6x squared minus x squared is 5x squared. Minus 2x minus 6 is equal to 1. Because I just got rid of this. To get rid of the 1, I do minus 1, minus 1. So I get 5x squared minus 2x minus 7 equals 0. Then I ask myself, is there anything I can take out of each term? And the answer is no. Then I look at it and I kind of go, oh, crap, I don't like this kind, but I have to do it. I don't like it for 2 reasons. First of all, there's something out front I have to deal with, and all those negative signs. So again, I'm trying to create with a positive and a negative. If you end in a minus, it must be a positive and a negative. I'm trying to create a negative 2. The question is, how will I arrange these? If I do this one times this one, I get a 35. That's way too big, and you should start to anticipate that. What that means is I'm going to need to link these together, so I have the 5, and these together, so I have the 7. So I'll be using a 5 and a 7 to create that negative 2. If I keep them both positive, I'm going to have a 12. If I keep them both negative, I'll have a negative 12. So again, one of them has to be negative. Right there, we'll do it. 5 plus a negative 7 gives me negative 2. So I know it's the 7 that needs to go negative. So now when I structure this, I'm going to have to go over here to do it. I'm going to lead in 5x and 1x, 5x and 1x. I'm going to end in a minus 7 and a 1, but I got to be careful who I linked with who. My 5 got linked to the positive 1. My 5 is on the outside, which means my positive 1 needs to be on the outside. That leaves me with the minus 7 on the inside, and it equals 0. These are very checkable, by the way. Before I move on, I might just want to do a little check. My outsides are 5. My insides are minus 7. Together, they add up to the needed negative 2. It's a very colorful one right now. All right. Now, before I move on, I have to figure out what makes them 0. So either 5x minus 7 equals 0, or x plus 1 equals 0. The one on the right is way easier to solve. X plus 1 can only equal 0 if x equals negative 1. Equivalently, you subtract 1 from both sides. So x equals negative 1 is a solution. On the other side, I have to add 7. I get 5x equals 7. And then I have to divide both sides by 5. So I'd get x equals 7/5. You can leave it like that. You don't need to go decimal. So again, this one was a lot more involved. Number 12, if you get that, that's about as hard as they get. It won't get much harder than that on a test. Let's move along. Do a couple more. Let's go try 16. Again, not ready to roll yet because I've got to move both of these terms over to this side to make it equal to 0. So I have to subtract the x, and I'll get a minus 6x. Then to get rid of the 8, I'll have to subtract that from both sides as well. So I'm sitting here with my equation equal to 0, which is exactly what I need. I always ask myself, is there something I can pull out of each term? And the answer for this one is yes. It's been no so far. But all of these are even, so they all can have a 2 pulled out front. I'm going to factor out a 2. When I knock a 2 out of 2x squared, I just get x squared. When I knock a 2 out of 6, I get 3x. And again, you're just dividing each term by 2. When I knock a 2 out of 8, I get 4. I like what's left because I like it when there's no number in front of this x squared because it makes my life so much easier. I only can start in x and x, and I won't have to worry about mix and matching. What multiplies to equal 4 that I can get a -3 out of? And think of that before you write them down. 2 and 2 can't be my winner, so you're wasting time writing them down. 4 and 1 have to be my winner. If I don't mess with the signs, they currently add up to 5. I want them to add up to -3, which throws a negative with my 4. So then back up, I have the 2 that I pulled out from the beginning. I'm leading in x's. One of them's a -4, and one of them's a +1. And remember, we want to multiply to equal 0. So what will cause this to be 0? Well, 2 can never be 0. 2 is a 2 is a 2. What would make x minus 4 0? And the answer is if x equals 4. You don't really have to go set it equal to 0, +4, +4. It's obvious to see that 4 makes this 0. Similarly, it's pretty obvious to see that -1 makes that 0. So I have two solutions, 4 and -1. Moving right along here. This one will be identical to the one up front. The only difference is you're going to substitute this in here. So I won't do this whole one, but I'll get you started. You're going to substitute that in. Then you're going to get one side equal to 0. I would suggest getting this side equal to 0 since there's fewer things over there. You'll subtract x squared. You'll add 2, and you'll go from there. And again, I want this to only take 15 minutes. So let's go do number 19. You can write academic lab by this one. Let's go do 19. I don't know if you can see it very well. See if I can move the screen down. I can't. Maybe I can. Sorry. There we go. Oh, that was lovely. Sorry, it's really sensitive today. Must be nicer to it, huh? All right, so let's go do number 19. What are the solutions? All right, well, this is already set and equal to 0, so I don't have to worry about that. My question is, can I take anything out of this, and this, and this? You should notice that those are all multiples of 3. So we're going to take a 3 out. When I divide out a 3, it gives me a 2x squared. When I divide out a 3, it gives me a 3x. When I divide out a 3, it gives me a 5. And again, you should anticipate, is this one I like or not? Definitely not. My favorites are like x squared minus 100. I love those differences of squares because I can rock those out in 2 seconds. Love those. Even if this had been a 9x squared, I just go 3 and 3. I like it when I have those differences of squares. My next favorite is when there's no number out front because it's so obvious to me that I just multiply to equal 15 and add up to 8. It pops into my head right away. You should know that this kind up here is my least favorite because I need to fart around with the front, fart around with the back, and get them mixed and matched correctly, and I have to watch my signs. So although I know I need to lead in a 2x and a 1x, there's no other option to get this 2 right there. My problem becomes, Sorry, I'm trying to move that back where it was. My problem becomes, how do I match them? So again, grab my highlighter here. If I multiply these first ones, that wasn't a highlighter. Sorry, I'll put that back on here. If I multiply these first ones, the 2 and the 1 and the 5 and the 1, multiplying these first two gives me a 10. I can't pair that anyway with the 1 to get a 3. But if I link them the other way, if I take them and link them like this, then I would have a 2 on the outside, and I'd have a 5 on the inside. I can definitely get that 3 out of the outside 2 and the inside 5, but I have to mess with the signs. Keep in mind I want it to be a positive 3. If I go like that, I'll create a negative 3. So I want to make sure I get my links correct. I would like to have a minus 2. So let's see how I linked that. I have my 2 on my outside, and I want to create a minus 2. So the negative 1 goes on the inside. That put a plus 5 here. I'm not done because I need to figure out what makes this 0. Well, you can almost do it in your head now, because the question is, what would make x minus 1 equal to 0? And the answer is 1. So this is out, and this is out. Between the other two, what would make this chunk equal to 0? Well, it's obviously not a negative 15. And if I had to show my work, I'd say, well, I subtract 5 and divide by 2. And that gives you B. So I think I'm at my 15 minutes here. But let's go take a look at one of the reviews. A snowshoe rental agency, the agency charges an initial fee of $120 plus $35 a day. $120 plus $35 for every day. A competitor charges $80 plus $40 a day. So my competitor in blue charges less, but they're charging me for a day. So again, if I'm not going to rent them for very long, I'd go with the blue company because it's less up front. But if I was going to be renting for a long time, I'd probably go with the red because they're only charging me $35 a day. The question is, when are they the same? So you solve this one by moving your D's over. And again, you can move them. I just like to avoid negatives, so that's why I'm moving mine that way. And I get 120 equals 80, right? These are gone, plus 5D. And then you guys can finish that off. You'd subtract 80, divide by 5, and you'd get the number of days at which the companies are the same. Awesome. Tomorrow you'll come in and we'll do the first day of test review. Make sure you're listening while you take the notes. I'm giving a big chunk of participation notes for those. Have a good one, guys.